Okay, so we're still in chapter 10, of course, and we're still discussing hypothesis testing. So today in hypothesis testing, we're going to discuss the conclusion step. So we want to make a conclusion based on our sample about our population. I have to give you some background first. So first, let's talk about the p-value. So we calculated this last class, our p-value, and I told you that the p-value is the probability. Right? So that's the area in the tails that we're calculating. So this is the probability that a sample will result in a statistic. Remember, a statistic's just from my sample. So what I mean is an X bar or a p hat here, that I'm talking about. Such as the one obtained if the null hypothesis is true. So remember, this is just kind of, sorry, it's crooked, telling us what that p-value represents, that probability. So my p-value is telling me the probability that I'm going to get another sample with an X bar if I'm studying means, or a p hat if I'm studying proportions, as far away from the center as I got from the first one, okay? If my null is true, right? Because the null was the center of my curve. So that's what the probability calculation was based on, the null being true, that it's the center of my curve, okay? So here for my conclusion, if my p-value is less than or equal to my alpha, remember alpha was that level of significance sorry, I'm like off the paper, that we picked out in the beginning. So way back in the second step or method step. So if my p-value is less than or equal to my alpha, then it is unlikely that the null is true. So let's think about what that means. So I'm saying if my probability is smaller than alpha, remember alpha we said is 5% most of the time. Sometimes we're given alpha. It's 1% if we're looking at medical. So it's a small percentage, 5% or 1%, right? Most of the time. Excuse me, I just had to sneeze. I knew it was coming. So we're saying if that probability is small, less than 5% or 1%, then it's unlikely that the null is true. So what we're saying is that if our probability is small, then maybe the null is not the center after all. Maybe the center is something different, something less than or greater than, like what we're stating in our HA. And that's our conclusion. So, and that's the idea behind it. So if my probability is small, then maybe my null is not true. Maybe that common view shouldn't be the common view anymore. And the new idea should be that view. And that's what we're talking about. So we have a few steps that we kind of take with our conclusion step. And just like any other step, we have like several little parts to it. And I kind of break it down that way so it's nice for us. So we're going to do the same thing. So let me just write conclusion step again so you know this is what I'm looking for. So for my conclusion step, we're going to ask ourselves this question right here. Is the p-value less than alpha? This never changes. It's always the same question. Is it less than or equal to alpha? Always. Never going to change this. It's never going to match like your HA. Some people like to think it matches your HA. It does not. It always is just less than or equal to. So that's my first thing. So is the p-value less than or equal to alpha? Right? And I have two ways of answering this question. So I can answer it with a yes or a no. So if I answer it with a yes, then we say we can reject our null hypothesis. So if my probability is small, smaller than alpha, then we're rejecting the null, meaning we're saying the null probably is not true. Okay. If we answered no, then we say we cannot reject the null. So if my probability is larger than alpha, so I'm saying no, it's not smaller, then we can't reject the null, meaning we don't have evidence from our sample to say that the null is not true. So it probably is true, or just our sample is not showing that it's not true. Okay. I want to give you a visual in just a minute. I want to finish with the steps so you know like the write-up, but I want to give you a visual to go along with all of this. And then you're going to make your conclusion statement. I will give you a statement you may use, but I will highlight and tell you the pieces that I will look for. So you do not have to use the same statement as me, but I'll let you know what parts of the statement I look for in a conclusion. So we can say at the alpha percent. So now I'm going to write alpha as a percent instead of a decimal. So instead of 0.05, I would say 5% here. Okay. Level of significance. And then I'm going to say can or cannot. And that's going to match up here. Can or cannot. Say that, and we're going to write our goal or our HA here, which is the same thing as the goal. I'm just going to write HA so we know. So what I'm saying is that at the 5% level of significance, if I answered yes, then I can say that the goal is true, basically. Or at the 5% level of significance, if I answered no up here, I cannot say that goal. So what I'm looking for in here, I'm always looking for basically the stuff that's underlined. My 5% level of significance, okay? You could say with an alpha of 5%, that would be sufficient, okay? But I do like to see level of significance because that's like my cutoff, right? If it's significant or not. So that's why I like to see that wording. And then I want to see that you can or cannot say, and then your goal. So you're saying that your sample does or does not support your goal, right? And your goal is what you wrote up in your population stuff. It's your HA written out in words, okay? So that's our conclusion statement. So I'm just going to highlight a couple things. So if we answered yes, then we can reject the null and we can say that the HA is true. If we answered no, then we cannot reject our null and we cannot say that the HA is true. Okay. And that's my conclusion step. It's like a really quick and easy step. It's nice because it sums it all up, right? So last class, the result step was kind of long. There was a lot of calculations. There was a lot of interpretations. And then this step just takes that and rolls it all up together and sums it up. It concludes it, right? So we can even say we can conclude, right? So let me just write that here. We can conclude, because if you use a word like conclude, you're saying you're summing it up, right? We can conclude that whatever our HAR goal is. So that's a good way of writing it too. You're welcome to use my statement here. You're welcome to use this, but you are not forced to use it. You may write your own conclusion knowing I'm looking for these few things. Okay. Any questions on that step? I'm going to draw a picture for you because I want you to get a visual to go along with it before we look at an example. So the visual I want you to see is where my sample is if we can reject the null or if we cannot reject the null, right? I want you to get that visual of what it looks like. So if I have my curve here, I don't know why I'm writing on an angle. Look at this. I'm like completely writing on an angle today. I'm sorry. I don't know. I don't think I was like this before lunch. Anyways. So if we have our curve here, our null is the center right here. Maybe we're looking at a greater than. Okay, so we're looking up here on the right. So let me just kind of fill this in, and I'm going to just use a blue. So maybe this is like my alpha, whatever it is, okay? My level of significance. Maybe it's given to me and it's 4%, okay? Maybe it's not given and it's not a medical problem, so it's 5%. Whatever it is, we're looking at this area in the tail right here, okay? That's what we're studying. We want to know where our sample is in consideration, so in comparative to my alpha. So when we're taking our sample, we're getting that test statistic, right? Then we calculate the probability. So if it's a greater than problem, like this one would be, because it's in my right tail, I'm calculating the area and the tail from my test statistic to the right. So it depends. I have two situations, right? So I have where it's going to be smaller than alpha or where it's going to be greater than alpha. So if it's smaller than alpha, then that means my test statistic is somewhere over here to the right. So that means the area in the tail to the right of this value is smaller than alpha. So this is my p-value that is less than or equal to alpha. This is where I reject my null hypothesis. Okay. Then the other situation is if my test statistic is over here, okay, further closer to the center than alpha, and the area that I'm calculating in the tail is all of this. And this would be my p-value that is greater than alpha, right? It's not less than alpha. So that means I do not reject. My null hypothesis. So this is our visual. This is what we're looking at. So I have my curve. If we're studying a greater than, I've got my alpha in the area in the tail over here in the blue, everything to the right. If my p-value is further from my center than alpha is, then it's smaller. That means I reject my null. That means I'm saying maybe this shouldn't be the center of my curve. You know why? Because my test statistic is so far from the curve. That means the probability of getting another sample that far away is small. So it's not that this sample was a bad sample. It's not that this sample is full of outliers. It's that maybe the center isn't the center. Maybe the center should be over here, closer to where my sample was. Do you see what I mean? So that's why we end up rejecting the null, because my sample's so far away. And then we're wondering, well, why is that? It's not that it's a bad sample. It's probably that this common view should not be the common view any longer. But on the other hand, if I have a p-value greater than alpha, so it means my test statistic, my sample was closer to my center of my curve, then we say, well, maybe that's not. Maybe that is the center. My sample's pretty close to the center. It's not that far away. It's not unusual. So maybe the center should still be the center. I don't have proof from my sample that it shouldn't be the center. So that's where I do not reject my null. So that's our visual to go along with it. This is just the right tail, right? Remember, you could have the left tail or the not equal where it's the two tail. So I just wanted to show you a visual so you could see what's going on. I always encourage you guys to draw these pictures because I think it's so helpful when you're studying anything in stats to have a picture, especially these probabilities. Okay, so let's take a look at a couple of examples. I want to pick up with the last two examples that we started last week, right? So we started a couple examples last week, one categorical and one numerical, and now we're going to finish those examples up. So it's kind of exciting to see how these are going to end up. So the one example, so I'm going to say from last week, and this was the example of the RIT students who approve of the university's admin, right? I'm going to just give you some information to recall so you don't have to flip through all of your notes, right? So we had our null and our alternative. So our alternative, which I always write first, or typically I do, is that the population proportion is greater than 67%. So remember that professor wants to show or prove to the community, the campus community, that more than 67% of our students approve of the admin. So that makes my null p is less than or equal to 0.67, or as you know, you can always write this as p is equal to 0.67. This is how you're going to see it in Minitab, and this is how you will see it in your homework, I believe. Okay, we collected a sample of 80 students, and I believe 62, yep, said yes. So we got p hat, which was the 62 divided by 80, and that was 0.775. Okay. We said our alpha should be 0.05, so 5%. So here it's important to now recognize what that is because we're actually going to use it now. We don't use this until now. Okay. So we calculated our z-test statistic last class, and we got the 1.9973. And we calculated the probability that we would get another z value greater than. You could use greater than or greater than equal to. In stats, it's not so cut and dry like it is in algebra. 1.9973. And that probability came out to 0.0229. So this is all the stuff we've done prior to this class. So now we want to go forward with our calculation. So for our, and when I say our calculation, I mean our conclusion, okay? So for our conclusion step, I'm going to say, is the p-value less than or equal to alpha? This is exactly how I would write it. This is how I want you to write it. Some people like to write the actual p-value, and that is sufficient. So maybe you could do this, is 0.0229 less than or equal to 0.05. Some people have a hard time looking at decimals and determining which one's smaller, which one's larger, and it's okay. Just view it as a percentage. So say, is 5% greater than 2.29%, right? So is the 2.29% smaller than 5%? Yes, it is. So much easier for most people to look at it as a percentage. And if you're one of those people, do it that way, right? So my answer here is going to be yes. So if I'm answering yes here, then I'm going to say we can reject our null, right? So yes, we can reject our null. So what I'm saying is that our sample is showing support to say that the null is not true. That's what I'm saying here. So now I want to always write my conclusion, not about the null, but about my goal, about the HA. So now I'm going to write the conclusion statement. So I'm going to say now I'm going to look at my alpha, it's 5%. So at the 5% level of significance, we can conclude that, and now I'm going to write my goal. Or when we look at our HA right here, right? My goal is my HA, right? So my goal is just my HA written out in words. So I have to remember what P was, right? P is the population proportion of RIT students who support or who approve of the university's admin. So I want to write it out in words. So I want to say that we can conclude that the population proportion of RIT students who approve of the admin is whatever this HA says, greater than 67%. Now I write it as a percentage in my conclusion. And I'm going to tell you why. Instead of a decimal, you can absolutely write it as a decimal. It means the same thing to me. If someone else was reading this, someone that's not in stats class, like you gave it to like one of your siblings or your parents, and they said, well, you're concluding that the population proportion of students who approve the admin is greater than 0.67, then they're kind of wondering, what the heck does that mean, right? Just someone that's not in stats class. If you say greater than 67%, it just clicks with people. So it's just more relatable. It's easier to read. So I always write this as the percentage here. Now remember, this is categorical. So if you're working with numerical data, it's a number. But so for my categorical data, I do write it as a percentage here. Okay, so I would be looking at this 5% level of significance. I would be looking for you can. I really like the wording conclude. And then I would look for all this population proportion and it's greater than 67%. So I'm looking for all of that context, right? I don't want you just to say P. I don't know what P is. I want you to tell me what it is. I want you to write a nice conclusion so anyone that's reading this understands, not just me. Any questions on that first example? I do want to show you guys how to do this on your calculator and on Minitab real quick, because I think this will be helpful. So our calculator and Minitab can do this for us. So I have to probably maybe turn out my light. Yes, so you can see. Okay, so I'm going to use my stat button here. So I have my calculator on and I'm going to choose my stat button. Look at this top option up here. It says tests. So I'm going to arrow over to test. Okay, this is the same place where we went for the confidence intervals, the CIs, but we don't want a CI. We have to think about what we're studying. Like we already mentioned, it's categorical data. I have one sample. So what I'm looking at is one proportion, okay? So if you arrow down, you can find where it says one proportion Z test. Two proportions, something you would we would do in stat 2, okay? And up here, these are more on the numerical side, so we don't use those. So option 5, so I'm going to get into that, okay? So now I want to fill this in. So remember what P naught is? That's my value from my null. So that's that common view. So that was that 0.67. Okay, it's the center of my curve. Then X, so I can tell it what it is. So X was, right here we can see, 62. And N was 80. Now, this next line, I need to match this proportion to my HA. If we look right here, my HA is a greater than. So I want to choose the greater than. This line always matches my HA. So I want this to be greater than P naught, which is 0.67. You see that? So I'm going to go down to calculate and then hit enter. Okay. And right here, all my statistics, right? This is my result step. Look at, I get my P 1.997. I'm sorry, my Z, wow, 1.997, my P value 0.02289, so I rounded to 9, right? Shows me my P hat and my N. So it does all those calculations from a result step for me. You don't have to do this. You can continue to always do it by hand, but this is another way of doing it, and I like to show you guys, okay? So that was the calculator. I now want to show you Minitab. So I have to first open a Minitab because I wasn't really thinking about doing this until just now. So I'm going to open Minitab and I'm going to share my screen. Okay, so I'm just going to open a blank Minitab file. So there's nothing in here, no information. And I'm going to go up to stat. And I'll look at basic statistics. And again, we have one proportion, right? We have one sample of proportion.
Excuse me, Professor.
Yeah.
When you're done with the Minitab, can you please repeat the calculator steps?
Sure, I sure can.
Thank you. Thank you so much.
So here I'm going to go stat, basic statistics, one proportion. Okay, so it's like right in the middle. I'm going to click on that. And when I'm here, I always have to tell Minitab how I'm going to give Minitab my data. So do I have raw data and it's going to be in a column? Most likely not. It's most likely going to be what we call summarized data, meaning I have X and I have N. So I know my sample size and I know how many people answered yes. Okay. It's in the same order as the division, X over N. So the number of events is X. That is my 62. The number of trials is how many people I sampled. That's my 80. So it's in the same order, X over N. Keep that in mind. Here, we can perform a hypothesis test. I'm going to check that little box. My hypothesized proportion, this is my null. So I'm going to type in 0.67 here. And then I'm going to click options because I need to make sure my HA is correct. So it won't be because it will always default to a not equal. So right here in the middle, alternative hypothesis, just like the calculator, I need it to match. It needs to be the greater than symbol. So it matches my HA. One other thing I need to change here is my method. So under method here, it says exact, it's a normal approximation. So I just need to change that, right? Because we check for normality. So I can click OK and then click OK one more time. And in Minitab, we're going to get all of that same information, just in a little bit of a different way. So you see N, X, P hat, right? So we got that in the calculator. This just confirms my null and alternative. So equal to 0.67, greater than 0.67. Here's my Z value. It rounded it. You can right click on here and you can expand your decimal places. There it is. I just did 16, 1.997. It just rounded it. So if you ever want to expand, this is the way to go. And then my P value 0.023, again, it just rounded. I can right click decimal place and then go out however many. There it is, 0.02289. So the same it was on the calculator. Okay. All right, let me go back to the calculator and just show that one more time. I'm happy to show this. So you just have your calculator on. You're going to click Stat, the Stat button right here. Once you're in Stat, you'll arrow over 2 times to the Tests up here on top. Once you're in Test, you will arrow down to your option. For me, it's option 5. It says 1 proportion Z-test, because I'm on the Z curve because it's categorical data. It's proportions, that's for categorical data, and I have 1 sample. That's what that 1 is stating, and then that's a test. So I'm going to get in that by clicking Enter. And then from here, I'm just going to enter all the information that it's asking for. So P naught, which is the center, the 0.67, X, and right here, my proportion will match my HA, and then calculate. And then you hit Enter, and there it is. So it's a really nice little tool. It's, like I said, you guys feel free to do it by hand if you want to do it by hand, but I don't want you to feel obligated. You're welcome. I don't want you to feel obligated to do it by hand. And I don't want you to feel obligated to use your technology for that. Okay, so it's whatever you feel like doing. So in that, in this one, we are showing support. So we are showing that the RIT students approve, that more than 67% of them approve the admin. So that's our conclusion. All right, so we have one more problem I wanted to go over, and that was the apple problem, right? So this is another one that we started last week, and we might as well finish it and draw the conclusion. So again, from last week, I don't know if that's better or not better with the light on. So from last week again, I'll just say it's the apples in a store. How about that? Again, I'm going to recall the information just so we have it all at our fingertips so we don't have to keep flipping back and forth. So we can recall our null and our alternative. So this is where the manager thinks that the apples in the store weigh less than 6 ounces. So weight is numerical. So we're studying means here. So my HA is that mu is less than 6 ounces. And that means my null is mu is greater than or equal to 6. Or you can always view this as just mu is equal to 6. Either way here. Just choose whichever way you want to write it. Okay, so we have our N, our sample size was 61 apples. We found the average of that 61 apples, the weight to be 5.6 with a standard deviation of 0.1 ounces. And our alpha here, again, was 5% or 0.05. When we went through the calculations last class, we found our t-test statistic to be equal to negative 31.24. Just looking at my test statistic, negative 31, that's really far away. I know right off the bat we're going to reject the null. It is too far away from 0, right? Because this is down to my standard normal, right? So where my t curve, where it's 0 is the center. 31 is really far away from 0, even if it doesn't matter if it's on the negative or positive side. So I know the area of my tail is going to be super small. Okay, so when we found the p-value, which was the probability that another t-value would be less than or equal to that negative 31.24, we found it to be very small. Remember, this is how we ended last class, and it looked like 0.00. We never report 0. We just always report it as very small. 0 means there's absolutely no chance it will happen. And that's not ever the case. It's just a very small probability. And when I say very small, it means it's smaller than 5%. Okay, so let's take a look at our conclusion here. We already know what the conclusion is. We already talked about it. But I'm going to ask myself, is the p-value less than or equal to my alpha? So is very small less than or equal to 5% or 0.05? And the answer is yes. So yes, we can reject our null. So this means that we can conclude that the HA is true, right? If we said we cannot reject the null, we would say we cannot conclude that the HA is true. Okay? So for my conclusion statement, at the 5% level of significance, we can conclude that, and now I need to write my HA in words. So if I had my whole problem in front of me, I would already have my goal, and I could actually just copy the goal and paste it down here. And that's what you guys will do on a test or something, or when you're doing work, because you're doing it all on the computer to hand it in, right? But I'm handwriting, I'm not going to copy and paste anything, but also I don't have my conclusion in front of me. So I need to restate my conclusion. So my HA is that the mean weight of the apples is less than 6 ounces. So that's what we're concluding. I'm just going to write this out in words. So we can conclude that the population, remember, it's always about the population. It's never about the sample here, right? That's what inferential statistics is. It's about the population based on the sample. So that the population mean weight of the apples is less than 6 ounces. And there's my conclusion. And I feel like if someone just off the street read this, they would know what we mean. They might be a little confused about the 5% level of significance, but I would hope that would kind of make sense to most people. It just means that that's my cutoff. That's how I know if something is significant or not, right? I'm using that 5%. Any questions on that one? All right, let's take a look at this on the calculator. I just wanted to make sure I'm in the right section on here. Okay, so again, turn this off again. So again, on the calculator, we will start at stat and arrow over to test. Keep in mind now we're looking at numerical data. So if you get confused, you could always, arrow down and look through, but think about what we have, okay? We have one sample of numerical data and we're on the t-curve. Oops, I didn't mean to go that far. So right here, I'm on the t-test. So it doesn't say one sample, it just is the one sample because the 2 sample would be down here, right here, number 4. And that's not what we have. That's step 2, not step 1. Okay, and everything else, like this is Z, Z, Z. It's not Z, right? We're on T. So if you were looking, for something to pop up, you wouldn't see anything else. So right here, I'm sorry, I keep going too far. Option 2, t-test. I'm gonna click on this. I need to enter my data. So I have 2 different ways of doing this. If I had data, so raw data, I can tell it data and then tell it what list I put my data in. I could do that way. If I have summary statistics, that means I know what X bar is and what S is, then I can use that. So I do know that. So my mu naught is actually my null. So in this problem, it was the 6 ounces, so 6. My X bar is what we found in the sample right here, 5.6. My S is 0.1, my sample standard deviation, and then my N was 61. Okay, Again, this last part here, I need to make sure it matches my HA. And if we look, my HA is a less than. So I need to make sure I come over to my less than and then hit enter to select it. I'm gonna go down to calculate and enter to select, calculate as well. And right here, you can see here's our test statistic, the -31. Here is my p-value. It reports it as 0. Again, it said 0 before. It's just very small. It's not going out enough decimal places. That's all there is to it. It's actually very small. Okay. Let me just show you in Minitab real quick. We have a few minutes, so I'd like to do that. So again, I'm going to share my screen to my Minitab screen. I don't have to open a new one. I can just stick where I'm at. So here I will go back to stat, back to basic statistics. So just like where we were before. And now we have one sample T. So it's one sample of numerical data, and I'm on the T curve because it's numerical. So one sample T. I'm going to click here. Again, in Minitab, I need to tell it how I have my data. This was very similar to my calculator, but it was all in a column, like raw data, or if it's summarized. It's summarized here for us right now. My sample size, so now I have to put all my information in, right? So my sample size was 61. My sample mean was the 5.6. And sample standard deviation is 0.1. I'm going to click perform hypothesis test. It needs to know what the null hypothesis is. It's 6. I'm going to choose options to make sure my HA matches, and it won't because it always defaults to not equals. So I always need to go in here and make sure. My confidence level doesn't matter. That's if you're doing a CI. It does not change your test output. So I never need to touch it. It doesn't matter what alpha is. Okay. But my alternative, I do need to change. It's a less than, right? So I'm going to choose less than and click OK. Click OK again. We have our output, the same output we get from our calculators, right? N, X bar, S, and then down here, it has my null, my alternative, my T, and my P. So let me see if I can even get, it's -31 is really far away. There might be more than 16 decimal places. It is, see, it's still showing 0. It's not actually 0, it's just really tiny. All right. So that's how we can use our technology to get our result step completed. Any questions on that for me, guys?